Alright, Chem 1 students, this is Mr. Bardwell here to help you with your first video on sig figs. Here's the situation for you so far. Basically, no matter which teacher you have in chemistry, there's pretty much two things you know for sure. One is that no matter who they are, they're probably pretty strange. And two is that they probably keep going on rambling about this weird sig fig thing, about how big of a deal it's going to be and how important they're going to be. Well, that's what we're here to talk about today. We're going to talk about what sig figs are and what we're going to do with them. Okay? Let's see if I can help you. First idea to get down is the fact that when we measure something, we're going to have a real world value. Okay? That means it has a certain accuracy and precision indicated with the value. For instance, your bathroom scale at home. It probably weighs to a single pound. Okay? Now, could we make a bathroom scale that would measure to a tenth of a pound, or a hundredth of a pound, or a thousandth of a pound? Sure, but why would you? I mean, what purpose would it serve? Why? Every time you breathe in and out, the scale would change. I mean, people are obsessed enough with their weight. Who needs that kind of accuracy, making everything even more confusing? So basically, the point is when we measure something, there's going to be a given amount of precision and accuracy with it. That precision and accuracy is going to tell us how many significant digits we have in our number. Okay? How many actual measured values. That's going to have to be accounted for when we do math. Because if we measure something with a very inaccurate measurement, we can't do math with that number and then later come up with a number that is somehow magically really precise. That's kind of a lie. Let me give you a couple more examples. Let's say, for instance, I've got a pet elephant. His name is Fred. Meet Fred, everybody. I'm going to weigh Fred. You know, just because it's nice to know whether they're healthy or not. You kind of keep track of the weights of your pets. So to weigh Fred, I'm going to go on down to the elephant store and I'm going to find myself an elephant scale. Yeah, stick with me here. So I'm at the elephant store looking for elephant scales, and they don't make elephant scales with a great degree of accuracy and precision. It's really just not necessary to know the weight of an elephant within a tenth of a kilogram or a hundredth of a kilogram or even to a single kilogram. They're such a big animal, right? It's not necessary. So my elephant scale is going to go ahead and round to the hundreds place of kilograms. Okay, so it's going to round to the nearest 100 kilograms when I weigh my elephant. So here we go. There we are. Fred weighs 2,300 kilograms. Now remember, that number is rounded to the nearest 100 kilograms. Technically, in reality, Fred could weigh 2,251 kilograms. It would round up to 2,300 kilograms in the scale. He could weigh 2,349 kilograms, and it would again round to 23 on the scale. Okay? That means that if we were to talk about which numbers are significant, which digits are actually meaningful, in this particular number, because there is no decimal point, we would say that there are two significant digits. 1 and 2. Okay? Now you're thinking to yourself, what are these zeros down here, right? Well, I said it rounded to the 100 kilograms, right? These two zeros down here do not indicate any sort of accuracy or precision. They are not significant. What they are is placeholders. You know, like some guy you pay to stand in line for you at a concert while you run and get something out of your car. They're just holding the place to indicate the magnitude of our actual measured values. The 2 and the 3 are the only actual measured values. The 2 we know for sure. The 3 is an estimate, right? We just said that it would round up based on whether it was 51 or 49 or whatever, right? So these two are significant. These two are placeholders. Alright, an example like you might see in class might look something like this. Let's say we weigh something on one of our gram scales. You know they're 3 decimal accurate, so if you weigh something and it tells us it is 0.023 grams, what that's basically telling us is only 2 significant digits. Those 2 are meaningful. They are measured. This 3 here would be an estimate that the digital scale is going to estimate for us. This 2 we're going to know for sure. These two zeros, again, are just going to be placeholders to get the proper magnitude of our number. They are not actually significant. Only placeholders holding your place in line, right? All right, let's take a look at what this is going to mean for us. When we report our measurements, we're going to indicate the uncertainty of a measurement in the system that we call sig figs, that thing that your crazy teacher has been rambling on about, right? Since our data can only be as precise as our least precise instrument, we need to round our final answer, and in some cases our answer after each different type of conversion, to the correct number of sig figs or sig digs for significant digits, okay? Based on the precision of the least precise instrument. This all comes down to the thing you talked about a while back when we did that lab in class where you had to get your lab drawer out and measure different things. Your teacher told you that they wanted you to estimate one digit past the precision marked on the instrument itself. Which means if you used a graduated cylinder, for instance, that was marked into the single milliliters, you would estimate to the 10th of the milliliter, one decimal or a digit past what is marked on the device. Here's how that's going to come into play with sig figs. Again, this might not make 100% worth of sense to you right now. I'm just kind of introducing the topic, and we'll go on in the next couple of videos here and talk about the different aspects of it. Just to kind of get you the overall thing here that we're talking about, let me kind of give you a summary here. Let's say I'm adding these three values together, okay? Obviously, they're all in grams. They've all been weighed on very different devices because some of them have a lot more precision than the others. So here we go. Adding these three together, here's the result as the calculator would tell you. Now here's the problem. When you did that lab, you learned that the last digit or decimal in every number, when you're dealing with real measurements, is an estimate. Okay? That means this 4 is really an estimate, right? It could have been 53.7, or it could have been 54.2. We basically have estimated that last digit or decimal. It's kind of a little white lie. In this number right here, this 10th place is considered to be an estimate. Okay? In this number right here, this last digit or decimal right here is said to be an estimate. So, when I add them together, this is the answer my calculator tells me. Fantastic. Here's the problem. Your calculator doesn't have a brain. You have to use yours. Your brain should turn on and think to yourself, let's see here, this is the ones place, right? Okay, well if that's the ones place, that means this number right here was an estimate based on that measurement, right? We weren't even sure if that was really a 4. So we're not even really sure that that's a 2. If I'm not really even sure that that's a 2, how can I possibly go on to say that I know for sure this is a 4? That's impossible, right? That's just a complete lie. Now you're just making stuff up. We round to the correct number of sig figs to really indicate the precision that we've actually determined. That's this whole big deal that we've been rambling on about, okay? Now, in the next video, we're going to go through and talk about how you can determine which digits are significant or not. You have two options in this case. All right, video A, or option A, is going to teach you kind of a shortcut trick to measuring the number of sig figs. Video B is going to show you kind of a more methodical step-by-step version of counting sig figs. You're welcome to use either one. It kind of depends on what works for your brain. Everybody kind of gravitates toward one's version or the other, so you go ahead and pick whichever one you think will be more successful for you. All right, so that's it for this video, and I'll meet you in the next one.